नमस्कार मित्रों, मैं एसएन सिन्हा चार्टर्ड इलेक्ट्रिकल इंजीनियर के साथ मैं अपनी फर्म ग्रीन एप्पल एनर्जी सॉल्यूशंस का फाउंडर एंड कंसल्टेंट भी हूँ। इस ट्रेनिंग सेशन में हम आपको सोलर एनर्जी को कैसे कैप्चर करते हैं और क्या मटेरियल यूज़ करते हैं उसके बारे में विस्तृत जानकारी देने का प्रयत्न करेंगे। ये हमने कई चैप्टर्स में बनाया है जिससे कि हम आगे के सोलर एनर्जी को यूज़ करने के संबंध में, सोलर एनर्जी की कॉस्टिंग के बारे में, सोलर एनर्जी की टेक्निकलिटीज़ के बारे में, क्वालिटी मैनेजमेंट के बारे में आगे डिस्कस कर सकें। तो इस प्रथम चैप्टर में हम आपको बताने जा रहे हैं कि जो बेसिक इंफॉर्मेशन है सोलर एनर्जी की वो क्या है। सो सोलर एनर्जी व्हाट इट इज। एज वी ऑल नो, सन इज द सोर्स ऑफ लाइट एंड हीट. सन जनरेट्स एनर्जी to the tune of 1.1 into 10 to the power 30 units per second. However, only 7 into 10 to the power 17 units per second reaches to the earth's surface. यहाँ ये बताने वाली बात है कि kilowatt hour per second, what we have written here is, in this kilowatt hour is nothing but 1 unit. So coming to the next point, however, average solar energy reaches to earth is only 0.8 units per square meter per day during winter and to around 4 units per square meter per day during summer. This is highest on equator, that is 1000 units per square meter per day to 2200 units per square meter per day in European equatorial region of Africa, Australia, desert area, etc. Their collection of means sun rays collection. How we do sun rays collection? Light and heat of sun rays is then collected by solar cells and heat concentrators respectively, as we all know. Solar cell converts light particle photons into the electricity, and concentrators collect heat to produce hot water and steam, etc. What is solar cell and module? Solar cell is nothing but silicon wafers. Silicon is a semiconducting material. When sunlight falls on it, the particle gets energized, ionized to produce positive and negative charged particles. And that is why the negative charge starts moving towards positive due to opposite polarity, and the current starts flowing from positive to negative. As we can see in the picture also, what is a module? A module is a systematically interconnected arrangement in rows and columns of wafers cells to get the desired voltage. Each cell is of the size of around 15 cm by 15 cm. When light falls on it, it produces around 0.5 volts DC. A panel is designed to produce about 34 to 36 volts. Above this voltage, not much benefit can be achieved due to cells' characteristics of receiving light and conversion into electricity, that is voltage. There are three different types of modules: polycrystalline, monocrystalline, and thin film, that is amorphous silicon. Solar module efficiency. As you can see from the graph is of current and voltage curve of solar cell and module. The point which is the maximum power point available in this curve is of the tune of 32 to 36 volts and a maximum current of 7.5 to 8 amperes. Above which it is not very beneficial, as we have already discussed. Monocrystalline silicon is homogeneous in nature. It is composed of one continuous crystal without any grain boundary. The orientation of silicon atoms and lattice parameters remains constant throughout the material. In a polycrystalline, silicon is composed of multiple small silicon crystals, whereas in hydrogenated amorphous silicon, on the contrary, is non-crystalline in nature. What is an array? An array is a set of two or more modules in a row connected in series. As you can see from the picture, a cell or wafer, when combined to get the desired voltage, maximum power point, is known as a module by adding number of wafers in one module. And when number of modules are connected in a row and rows and columns, then it becomes an array. How solar cell converts light into electricity when sunlight falls on it. So when we see that the light falls on silicon wafer cell, it, due to its characteristics of semiconducting property, it has concentration of negatively charged particles and positively charged particles, that is the N-type silicon and P-type silicon. And when sunlight bombards on it, the particles get energized and loosely bonded electrons comes out from the atoms and start moving towards opposite poles and generates electricity, which is then collected and used for beneficial purposes. The other characteristics of these two different types of wafers, that is amorphous silicon and crystalline silicon, are tabulated in this the optical electrical conversion efficiency of amorphous silicon is around 14% only, whereas in crystalline silicon, that is polycrystalline or monocrystalline, it is ranging around 22.3 to 26.1%. The other characteristics are also to be seen while selecting the silicon module and wafer. So दोस्तों, इस चैप्टर में हम अभी आपको इतना ही बता रहे हैं. इसके बाद अगले चैप्टर में हम आपको ले चलेंगे कि how these arrays are made, what material we should take, and how these are connected in circuits, what are the other components used, balance of material used in installation.